So we're coming to you live instead of 6 o'clock, 6:15, to talk a little bit about the event that's unfolding in the western sky tonight between the planet Venus and the brilliant star cluster, the Pleiades. If you're tuning in from the East Coast, it's probably dark out there at about 9:15 p.m., still light out here at 6:15. But we wanted to give you a quick overview of what's going on in the sky tonight. And so to start off, we've got our educator, Nina Hoover, who's going to come online here for a little bit and talk to you about the general circumstances of what's going on this evening and why we see things in the sky very close together. So thanks for your patience while we sort out the technical issues, and I'll turn it over now to Nina.
Thanks, Jeff. So I'm Nina. I'm an educator here at Lowell Observatory, and I'm going to be talking to you tonight about the conjunction between Venus and the Pleiades. But before I do that, I'm going to explain to you what conjunctions are, why they happen, and some cool stuff about them. So we are going to start my presentation and get going. Okay, so all of the planets in our solar system, they orbit around the sun, and they orbit around the sun on this more or less so flat plane that looks like this. And so we can see here all the planets are orbiting around the sun in the same plane. And so sometimes while we're looking in the night sky, it kind of looks like a planet is just drifting about. And this is because the planets can't really move outside of those planes. That's kind of solely where they orbit. And so because of that, here on Earth, it looks as though the planets are just kind of traveling in a line through the sky. And that is known as the elliptical. And sometimes when planets are following their paths, just going along, minding their own business, it appears that they get really close to another object in the sky. And that could be a moon, a star, or another planet. And that is a conjunction. And so a very simple definition of conjunctions is when two or more celestial objects are near each other in the sky. Now, it is important to note that these objects are not actually close together in the sky. And instead, they only appear close together based off of our position on Earth. And so here's a diagram kind of explaining that. So right here we have the Earth, and then we have Venus and Jupiter. And so this would be a conjunction of Venus and Jupiter. So as we can see, Venus and Jupiter are really far away from each other, but they are both in what is called the observer's line of sight, which is this line right here. And so on Earth, it would appear that Venus and Jupiter were pretty much side by side like this, when in reality, they're very far away from each other in the sky. And so that's how conjunctions work. Now, conjunctions have had some pretty important historical significance. So a lot of ancient civilizations relied really heavily on astronomy for their day-to-day life. And so they would use cues from the sky to figure out when they wanted to plant and harvest their crops. And certain ancient civilizations, such as the ancient Egyptians and the Mayans, actually used astronomical observations to construct calendars. And so because these ancient civilizations relied so heavily on astronomy, it makes sense that they would note astronomical phenomena such as conjunctions. However, conjunctions were considered a bad omen by a lot of ancient civilizations. And so they were oftentimes associated with natural disasters, particularly floods. That was the most common natural disaster. And so an example of this is not super ancient, but from 1524, there was a conjunction of 5 planets, and the revered religious figure, Martin Luther, he saw this conjunction and he stated that this conjunction was a warning from God and that a great flood was coming and that the world was going to end. And so here's a picture of that situation. The planets were aligned in the constellation Pisces, which is represented in this photo by this very large fish in the sky. And then here are those planets that were in conjunction. And then this yellow stream was a representation of the flood, which was supposed to cause destruction and eventually end the world. But that did not happen. And so it makes a lot of sense that ancient civilizations would view conjunctions as bad omens, because a lot of ancient civilizations actually thought that the planets and other celestial bodies were physical manifestations of their gods. And so when these objects were getting close to each other, they kind of thought that it was going to be a literal clash of the titans, which would be pretty frightening for anyone. So it makes sense that these natural disasters were anticipated as a result of conjunctions. However, not every ancient civilization viewed conjunctions with destruction or natural disasters. In fact, some ancient civilizations actually viewed it with creation and also sometimes destruction. So on the left here, we have the Greek philosopher Plato, and in his book Timaeus, he wrote, the great year began with the meeting of the planets, which could be translated to the conjunction of the planets. And then in 300 AD, a Babylonian man wrote that the world began with the conjunction of 5 planets, and it would also end with the conjunction of 5 planets. And conjunctions were even mentioned in the work of William Shakespeare, who is pictured on the right. In his play, Henry IV, he wrote a line from Prince Henry that said, Venus and Saturn in conjunction, what saith the almanac to that? And so during Shakespeare's time, astrology, not astronomy, was used a lot to make predictions about things that were going to happen in life based off of astronomical observations. And so, but the fact that Prince Henry in this example is questioning what these like books that they would write filled with these predictions are saying, it shows that he's a little bit concerned about what this conjunction means. And it shows that even in Shakespeare's time, conjunctions were regarded as mysterious and potentially powerful astronomical phenomena. And so conjunctions are actually a lot more common than you might think they are. They happen pretty frequently because their definition is pretty loose. It's just 2 or more celestial bodies that are near each other. And so one example of a really common conjunction that you may not think about is a solar eclipse, which is a conjunction between the moon and the sun. And this happens roughly every 18 months in various locations around the Earth. So pretty common, but conjunctions can also be really rare. So an example of a rare conjunction is the conjunction between Saturn and Jupiter, which is regarded as the Great Conjunction. That's what they call it. And this only happens every 20 years. And this would look something like this picture right here with the 2 of them very close together in the sky. The last time this happened was May 31st, 2000. And the next time it will happen is late December of 2020. And so that's another conjunction that you'll get to look forward to. And you can be sure that us here at Lowell Observatory will have some telescopes pointed at it. So you'll be able to see that, hopefully. And so the conjunction that is happening tonight is between the planet Venus and the open star cluster, the Pleiades. And so you can kind of see from this diagram, Venus is going to get really, really close to the Pleiades. And if you've ever seen the Pleiades, you'll know that they kind of look like a really, really, really miniature version of the Little Dipper. In fact, they're commonly mistaken for the Little Dipper. And so this conjunction will be visible in the night sky April 2nd, April 3rd, and April 4th. But it is the most spectacular tonight, April 3rd, because Venus is going to be the closest to that cut part of the Pleiades. And so here's another view of what that might look like as Venus is coming towards the Pleiades. These stars right here that I'm outlining with the mouse, those make up the Pleiades. And then this bright orb in the sky is Venus. So it's going to look something like this, hopefully with Venus even closer to this kind of cut portion of the Pleiades. And so this is a conjunction that occurs once every 8 years. So it's kind of a more common conjunction as far as things are concerned. And then it's also worth noting that, like we talked about earlier, Venus and the Pleiades are not actually close together in the night sky. In fact, they are about 400 light years apart. And so we're not seeing them together. We're seeing something like this, which I don't know if you can, here we go. So here we have the Earth, and then this line of sight, we have Venus, and then we have the Pleiades. So the Pleiades are going to appear above Venus like this, and then Venus is going to be somewhere in the middle, and then Earth is going to be right here. So we're kind of viewing all of those lining up together based off of Venus's orbit and the Earth's orbit and the location of the Pleiades. And so that is all I have for my presentation, and we can go ahead and open it up for questions now. Okay, so no questions.
Okay, thanks, Nina. So now we know a little bit about the geometry of what's going on in the sky tonight, a line of sight coincidence between Venus and the Pleiades. So we're going to switch now to talk a little bit about each of these objects. And the first one will be the planet Venus, the next planet inside the orbit of the Earth to the Sun. And to tell us about Venus, we have our educator, Ariel Danielle, online with us tonight from her residence in Flagstaff. We're doing all of this from our respective homes rather than from up here on campus, as we hope to do. So I'm going to turn it over to Ariel to tell you all about our so-called sister planet.
Wonderful. All right. Hi, my name is Ariel. I'm an educator here at the Lowell Observatory. So Venus is known as Earth's sister planet solely for the reason that we're just about the same size. Besides that, Earth and Venus are incredibly different planets. So you've probably been seeing Venus in the night sky. It's towards the western horizon, and you've most likely mistaken it for a star. Besides the moon, Venus is the brightest thing in the night sky. Because of this, Venus is known as our morning or evening star, meaning as the sun is setting, usually it's the first thing you see in the night sky, and as the sun is rising in the morning, it's the last thing you see, besides like the sun. When astronomers talk about how bright an object is, they usually use the term albedo, which refers to how much light that object reflects, therefore making it brighter. So 0 albedo means doesn't reflect anything. 1 albedo means 100% reflective. Venus's albedo is about 0.7, meaning it reflects about 70% of the sunlight that hits it, making it the brightest planet in our solar system. Now, since Venus, is an inner planet, we are able to see it in phases similar to our moon whenever it's in our sky, ranging from crescent to a gibbous phase. Since it's closer to the sun than we are, though, we never really see it in a full phase. This makes it look like a tiny little moon through a telescope. So off over to the right, there's a picture of the moon, and then just below it, you can see a crescent Venus. Venus rotates backwards, meaning that instead of seeing the sun rise in the east and set in the west, like how we do on Earth, with Venus, it rises in the west, or the sun rises in the west and sets in the east. Also, one rotation or 1 day on Venus takes about 243 Earth days, and 1 year on Venus takes 225 Earth days. So a day on Venus is longer than a year on Venus. Now, the reason why Venus is so bright is because of its atmosphere. Venus's atmosphere contains these highly reflective clouds of sulfuric acid. This also means that it will occasionally rain acid on Venus. This planet has a very thick atmosphere, so when we're looking at it with the naked eye or even at our telescopes at the Open Deck Observatory, we can only see Venus's atmosphere. The atmosphere is almost 97% carbon dioxide. When compared to Earth, we have about 0.04% carbon dioxide in our atmosphere. So on Venus, this creates a runaway greenhouse effect where the sun will beat down on Venus and the heat will become trapped. This makes Venus the hottest planet in our solar system with a surface temperature of nearly 900 degrees Fahrenheit. This means that you could melt lead, but you could also cook a pizza in 6 seconds. I don't know. Even though it's the second closest planet to the sun in our solar system, because of the excess in atmosphere, it is our hottest. Now, since that atmosphere is so thick, there's a tremendous amount of atmospheric pressure. Here on Earth, at sea level, like to put it into perspective, we experience 1 ATM, or 1 atmosphere. So that means that at sea level, we feel about 14 pounds on every square inch of us. However, we can't really like feel the equivalent of 1 fat cat on every square inch of us because we're used to that kind of a thing. But Venus, on the other hand, has 92 ATM, or 92 atmosphere, meaning 92 times the amount of atmospheric pressure that Earth has. This means that if you were to stand on the surface of Venus, you would feel the equivalent of 4 fully grown panda bears on every square inch of you. So I have not tried it and would not recommend. The wind speeds on Venus are incredibly high, averaging over 400 miles an hour. This means that it only takes 4 days for Venus's atmosphere to take the wind around the entire planet. Now, there is a solid surface of Venus that has been mapped before with spacecraft, as well as physically visited. A series of the Venera missions were successful in imaging Venus's surface. So Venera 9, which is on the very top there, or images of the surface from Venera 9 is visible on the top there, was the first successful mission to image Venus's surface from the surface. But there was an issue with the lens caps. So instead of getting like a full 360-degree view of Venus's surface, they were only able to get 180 degrees of the floor, which is fine. We can still work with that. We can still get data from that kind of a thing. Venera 10 landed about 5 days later and had the exact same issue. So another image of the floor, but again, we can work with that kind of a thing. Those bottom 2 images were taken with Venera 13. That was the first probe to send back colored images from Venus's surface. Although Venera 13's, through Venera 13's image, we can kind of see that visibility on Venus is sort of like visibility in a dust storm. So that really, really thick atmosphere, you'd feel it on you, but you can see a pretty okay distance. You can see a good while in front of you. Now, because of Venus's awful surface conditions, Venera 9 lasted less than an hour on the surface. Venera 10 lasted about an hour. And Venera 13 actually lasted over twice as long, at about 127 minutes before it went silent. Now, the Magellan spacecraft was able to fully map Venus's surface through radar imaging in the early 90s. So this image off to the right was taken by Magellan, and the images off to the left were built off of the Magellan maps. So at this point in time, we were able to fully grasp Venus's surface features. Now, through radar imaging, we can see volcanoes that are most likely still active. So Venus is alive, it's doing its own thing. Spikes in sulfur dioxide have been detected by the Venus Express mission recently, which is currently studying Venus, and those spikes are indicative of recent volcanic eruptions. Ancient and current lava flows can be seen in the computer-generated Magellan radar image off to the right, and other volcanic features can be seen covering the majority of Venus's surface through these radar images. To the left on this slide, we can see what's known as crater farm, and that illustrates a layering of volcanic activity and impact craters. So we can see all of this volcanic activity covering the entire planet. So if anyone has any questions, feel free to ask them. And in conclusion, Venus may not be doing too hot. Well, actually, that's exactly what she's doing. But anyways, she's pretty and she's doing her best, and that's all we can ask of her. So thank you for hanging out. We do have questions. Okay. Is there a more technical definition of conjunction rather than just being close? Nina, would you like to answer that question?
Sure, yeah.
Wonderful.
So a more technical definition is that 2 astronomical objects have the same right ascension. And so it's pretty much that they reach their minimum angular separation in the sky as viewed from Earth. And so it's kind of like those diagrams that I was showing earlier. So they're not actually close together. They just appear close together, but it's because of a combination of like the other objects in their orbit. and our orbit. And so they appear kind of like one is like really far out and one is kind of close in the middle, if that makes sense. And so all of them are in this line of sight. And so they're all in this right ascension, which would be, a more technical way of describing it. But it's easier just to say that they're really close together, or they look close together. Yeah.
Nice. So Mira asked, if Venus's rotation is so slow relative to Earth with a similar mass, why are the winds at such a higher velocity? A big part of that is the sun and solar winds and that sort of thing all colliding together, creating those intense wind speeds. Angelica asked if you'll be able to see this without binoculars. Absolutely, you'll be able to see this without binoculars. The Pleiades is visible in the sky with your naked eye. Again, Nina mentioned earlier, it sort of appears as like a super, like a micro dipper, like a super itty bitty mini dipper. It'll be in the western sky tonight, and Venus, it's hard to miss. It is the brightest dot in the sky besides the moon. So you'll be able to see Venus very bright in the center of the little star cluster Pleiades. Thomas asks, when you say it rains acid, do you know the pH balance? I believe it is like -1.2 balance. Magellan did not use X-ray. Magellan used radar imaging. So Richard asks, what contributes to the very slow rotation of Venus? So yeah, the orbit is very quick because it is close to the sun. You're really close to that center of mass, so it will rotate pretty fast, or orbit the sun pretty fast. But the slow rotation, not quite sure, not 100% sure. So like tidal locking, the tidal locking of Venus would slow down the rotation. So with that, thank you guys so much for hanging out with me.
Thanks, Ariel. And since we've talked about the physical properties of Venus, now we'll switch a little bit to some of the work about Venus that's been done here at Lowell Observatory. And for that, we will have our historian, Kevin Schindler. In addition to bringing stuff to folks online, we for 125 years have focused on astronomical discovery and learning more about the nature of objects in the universe. And Kevin will tell us a little bit about what's going on with Lowell research on Venus.
Thanks, Jeff. And I'll point out that I haven't been at Lowell for 125 years, although in the last few weeks it might seem a little bit longer. And I just have to comment, from where I'm sitting, I'm down about a mile from Lowell Observatory, and I'm looking up from my living room and I can see Mars Hill and the Clark Telescope Dome. And I can only imagine what Percival Lowell, our founder, would have thought, seeing this conjunctions, because he certainly saw at least a couple of them while he was out here. So, it's kind of fun to go back and think of what he would have been seeing and what he would have been writing about. So I'm going to put a slide program up here, and we'll talk a little bit about historic research about Venus at Lowell, and then I'll also do a little bonus round about the Pleiades. So if we're going to talk about some history of Lowell Observatory, we got to talk about this guy, Percival Lowell, who came from a wealthy family. At 39 years old, decided to build an observatory here in Arizona, which was 18 years before statehood. There were 800 people in town. There's no electricity. It was really the Wild West. And here's this Eastern guy coming and set up an observatory. And he did this because he was especially interested in Mars and proving the existence of intelligent life, but he was also interested in a lot of other things. And he did study Venus. In fact, I start with this picture. Is great because this is sort of an iconic image of Percival Lowell. It shows him sitting at the 24-inch Clark telescope, and this is much what the dome looks like today, minus Percival Lowell. But this picture was taken in 1914 while he was observing Venus. And so when you look at some of our old logos or pictures and you see this picture, realize that he's actually looking at Venus. So, Percival Lowell, as I mentioned, he's mostly known for Mars and wanting to prove the existence of intelligent life there. And this is one of his drawings. And just to kind of recap what he thought, this is a drawing. There's polar ice caps. There's the northern cap right here. And what Percival Lowell thought was that there was a civilization there that was dying. They needed water, so they built these canals, these linear features all across the surface, bringing water from those ice caps down to the rest of the planet, to these circular areas that he thought were cities. And so this is what a lot of his theory was built around. And here's another picture. And if you look closely, it looks very similar. But keep looking closely. If you look at the top, it says chart of Venus. Now, this really got people interested because, maybe Lowell was seeing something on Mars with these linear features. But Venus, even back in the late 1800s, astronomers thought, Venus is covered by clouds, we think. How could you see these features like this? Percival Lowell called them spokes. And today we know that the canals and the spokes are not real. They're illusory, something, they're not real, but they're based on something. One of the best explanations, or most interesting ones I've heard, has recently been championed by my good friend and astronomy historian Bill Sheehan. And the picture on the right shows that drawing of Venus. The one on the left shows a picture of the reflection of an eyeball with the blood vessels. And this theory holds that he was actually seeing reflection of his blood vessels, which other people would have seen also. So it's kind of an interesting history that Lowell has with Venus. And I'll talk about something else in a couple minutes that Percival Lowell did. Now, when Lowell started his observatory, it wasn't long till he had a small cadre of astronomers around them. And that was the core of the observatory for a long time. And they studied a lot of things, but initially Lowell Observatory was really a planetary center. So they studied different planets. One of those early astronomers, his name was Carl Lampeland. And Carl Lampeland was a whiz with instruments, and he built this machine called a radiometer to measure temperatures, including the temperature on Venus. And some of his research is still used by astronomers today. In fact, just a couple of years ago, his name was on a publication. He's been dead since the 1950s, and yet his research is still so useful that he was put on as an author of a recent scientific paper. Another early astronomer here at Lowell was E.C. Slipher, the fellow on the left. And E.C. Slipher, besides being a remarkable astronomer, he was a world expert on Mars, and also one of the most accomplished astrophotographers in the world. He was also a community guy. And I like to mention him because he really represents, I think, what Lowell has been through the years, part of the community. It's not just, Lowell Observatory up on the hill. We have people like E.C. Slipher, who was the mayor of Flagstaff at one time. And that's why we try to do these videos that we're doing now and outreach, is this continuing effort to share the excitement of astronomy with the community, Flagstaff and beyond. So E.C. Slipher did a lot of photography, including Venus. And it's interesting to mention him because he was one of the earliest scientists to experiment with stacking images, which is a standard photographic technique in later years. This is a compilation of images of Venus from one of the books he published on the brighter planets. And if we're going to talk about E.C. Slipher, we sure have to talk about his brother also, who also did work on Venus. His name is V.M. Slipher, Vesto Melvin Slipher. Both brothers worked their entire career here at Lowell Observatory as astronomers. Well, if we go back to the late 1890s, Percival Lowell was studying Mars, but he was also studying Venus and taking some pictures and mostly drawings he was making of those spokes. But he saw some features of Venus he thought he saw. And at the time, most astronomers thought Venus rotated really rapidly, like every 24 hours. But Giovanni Schiaparelli, who was the first person to see the canals, he also did a measurement of Venus' rotation and said, no, it's more like 200 plus days. Well, Percival Lowell came along, and seeing some of what he thought were features on Venus, he measured the rotation, and he came up with a very slow rotation also, 200 plus days. But he came under a lot of criticism for this. And so he decided he wanted to get a spectrograph this instrument shown here, which when attached to the telescope allows you to not only identify what distant objects are made of, but also their relative motion away from us and towards us. And VM Slipher made many important discoveries with this instrument, but the reason we got the instrument in the first place and the first thing he did with it was proving by spectroscopy that Venus did in fact move very slowly. And as we heard earlier, it's actually slower than it takes longer than its year. So VM Slipher did this research, but it was really leading up to something else when he discovered the first evidence of the expanding universe, which is what he's most remembered for. But what I'd like to end up with is also something else he worked on, and that's the Pleiades. Because in looking at the Pleiades, he realized that the gases around this were reflection nebula, and this proved the existence of interstellar dust, which is something that's kind of a footnote when we talk about VM Slipher today, but it's a really important discovery. So those are just a few basic historic research projects with Venus, and then a little bit with Pleiades, which I'm only talking about it briefly, but it was really critical. What I'd like to end up with is something a little bit of fun that has almost nothing to do with astronomy, but it has to do with Lowell Observatory in Mars Hill. If you go up to the observatory, you'll come up this direction. Here's the new road, and come up this way, and the observatory would be, or the visitor center on the right. So this view is looking down. This picture was taken in 1938 when this new road was put in. The old road went back this way, past Jeff Hull's house and down. But in this picture, you see this barn. That barn was there until the 1940s. The reason there was a barn there is because there used to be horses and cows up here at Lowell Observatory. And this is Percival Lowell, the cow. And the cow that he is with, the big one, is named Venus. And its little baby they named Satellite. So I had added that in there just as a means of ending on a good note about Venus. So let me turn this off. That's just a little brief introduction. And if anybody has any questions, we'll be on here for a minute. When you think about what we're talking about tonight, we've been doing research here at Lowell Observatory for more than 125 years, and we're just touching the tip of the iceberg of what the universe has to unfold. And so what's so exciting about this is we have this great history. It's just the foundation for what's still to come. And that's where it's exciting to listen to people like tonight, Jeff Hall and Joe Llama, who are doing this cutting edge research. And in future programs, we're going to find out what they're discovering. So we're really excited to have you on board, and thanks for tuning in.
Okay, thanks, Kevin. And certainly agree. The more we study the universe, the more we realize we don't know. So what we will do is move now from our very nearby celestial cow, which is about to come out here in Flagstaff. It's just about 10 of 7, 10 of 10 over on the East Coast, just getting dark here on the West Coast. So having heard a bit about Venus, we want to switch now to the other celestial object that's featuring prominently in the western skies tonight, and that is the Pleiades star cluster. And we're going to talk about both what the Pleiades is, as well as some of the cultural interpretations of the Pleiades. And so for the former, just to give you an overview of what the other object is there, I'm going to turn things over to our educator, Victoria Girgis, who's here tonight to tell you a little bit about the star cluster that Venus is passing just past tonight. So, hi, Victoria, take it away.
Hello, everyone. Thanks for the introduction, Jeff. I will be talking all about the Pleiades tonight. And to start us off, let's talk about where the Pleiades are. You might be familiar with Orion and his bright belt over here. The belt of Orion actually points straight through another open star cluster called the Hyades over here to the Pleiades. The Pleiades are this one I have outlined in red here. The Pleiades are very noticeable in the night sky. Even in a place with moderate light pollution, you will probably be able to see at least a couple of the brightest stars. Typically nowadays, there are 6 stars visible in this little cluster here. However, historically, there have been up to 7 visible with just the naked eye. As such, ancient people who followed the night sky for various purposes, including timekeeping and watching the years go by, they kept note of this little star cluster over here. The name Pleiades comes from the Greek mythology, and in Greek mythology, Orion over here, the great hunter, was intending to pursue the Pleiades romantically, and they did not want any part of that. And so or in order to protect them, Zeus put them into the sky to keep them away from Orion. And if you think of Taurus the bull, who ends up in between the two, you can think of Taurus as protecting the Pleiades. There's also a Native American legend that comes from Wyoming. And it also involves the creation of this national monument here called Devil's Tower. In this Kiowa legend, there were 7 young girls playing by a river when a pack of bears pursued them and decided to attack. So the girls ran away, but they couldn't run away fast enough. So instead, they prayed to the Great Spirit and said, "Please save us from these bears." And the Great Spirit lifted up the rock underneath them straight up into what is now known as Devil's Tower, this great rock formation that stands straight up. And then the bears attempted to climb up the sides, and that is where these long vertical stripes come from. You may be pretty familiar with the shape of the Pleiades, and if you are, that might mean you drive a Subaru. The logo of that car brand is actually these stars, and in Japanese, they call the Pleiades Subaru. But what exactly are the Pleiades? The Pleiades are an open star cluster, so it is a whole bunch of stars. The Pleiades in particular number at about 1,000. There's about 1,000 stars clustered right all together in this little section of the night sky. We only see the brightest 6 or 7 of them. But all of these stars likely form together. Stars form, oh no. Oops, there we go, sorry. Technical difficulties. So stars form together from big clouds of gas and dust. This image here is of the Eagle Nebula, and it was taken with one of our telescopes up at the Giovanni Open Deck Observatory back in September. But the Eagle Nebula is a stellar nursery, so it is a big cloud of gas and dust, mostly hydrogen gas, that will make baby stars. The vast majority of these stars you see here were all formed from this nebula. What happens is the gas in this nebula sticks together. It'll form a molecule, and then from there it will build up, and more molecules of hydrogen will stick together. And after a while, you end up with a big clump of hydrogen. And through the force of gravity and molecular forces, it begins getting denser. So all of the material pulls together more tightly. Then this big ball of hydrogen will start performing thermonuclear fusion. So in its core, the young star will take 2 little hydrogen atoms and smash them together. That process releases a lot of energy, mostly in the form of light. This is how stars generate their energy. And this is where they start as well. They start out from these big clouds of mostly hydrogen. The Pleiades are the next step up from that. So stars form from these big clouds of gas and dust, and they all form together. You don't just get one star. I always like to compare them to kittens. because you never end up with just one kitten. Like in a litter of cats, you very rarely just get one. So you have all of these young kittens, and as much as you want to take care of them all, you can't. So you start giving them off to your friends, and you slowly but surely spread them out. Stars do the same thing. The stars all form together. They form in this big clump. But as these stars grow a little bit more, they start taking on the gas and dust around them. The Pleiades here are just beginning that. So this is a long exposure picture of the Pleiades that shows this blue haze around them. That blue haze is the leftover gas from the Pleiades forming. And with time, the individual stars in the Pleiades will take on that additional gas and either add it to the star itself, or they will create a solar system. Additionally, the Pleiades here will spread out. So as all of these stars orbit around the center of our galaxy, they will move apart from each other. Each star is trying to find its happy orbit, where it can move around the center of our galaxy in a stable way. And each and every star, that will end up slightly differently. And so given enough time, the Pleiades will spread out from each other. It's likely that the sun was once formed from a similar cloud of gas and dust with a similar group of stars like the Pleiades. And we've since just moved away in the past 4.5 billion years from those other stars. And I believe to date we found one other star that was likely one of our sun's siblings. But given enough time, the Pleiades will spread apart from each other. These stars are relatively young. They're only about 100 million years old, which compared to things like our sun, which is 4.5 billion years old, that is pretty young. These stars are still just in the beginning stages of their lives. Additionally, while they might look very close to the planet Venus, this evening, they are not. The Pleiades are about 400 light years away. Typically, estimates go about 420 to about 440 light years away. So they're awfully far, but in the grand scheme of things, that is close to us in the scale of our galaxy, at least. Being rather close to us compared to other stars, the Pleiades are very nice to view. You can see them with your naked eye, especially in a dark area. You can see up to 6, depending on your glasses prescription. They were historically used as an eye test as well. But the Pleiades also shine particularly well through things with a wide field of view because they take up a large chunk of the night sky. Things like binoculars or a wide field telescope, like our 5.5-inch Tech telescope up at the Lowell Open Deck Observatory, make the Pleiades really twinkle, for lack of a better word. That was about all that I had, but I would love to entertain any questions. All right.
Okay, thanks, Victoria.
Of course.
So, as Victoria pointed out, the Pleiades are near Orion, and there are this set of stories in Greek mythology that connects them to the ancient hunter. But we also heard about how there are Native American stories, and you know, the stars in the sky are things that humans have used to communicate and transmit stories for thousands of years. And what we're going to do now is switch to one of the other cultural aspects of the stories behind the Pleiades, and hear a bit about the Arabian interpretation of this phenomenon in the sky tonight. And for that, we're going to turn it over to Lowell's Deputy Director for Marketing and Communications, who is a cultural astronomer, as well as being an outstanding videographer and marketer, Danielle Adams. And she's going to tell us all about the Arabian side of what's going on in the sky tonight.
Thanks so much, Jeff. It's great to be here. I'll get started here on the share of my presentation. So we've been learning about the Pleiades across multiple cultures in Victoria's presentation. And now we're going to do a little bit of a deeper dive into one old cultural group, Pleiades in Arabia. Now, to start us off, we're going into the realm of cultural astronomy. And just simply, cultural astronomy is the study of how societies relate to celestial objects and their appearance in the night sky. Our latitude here in Flagstaff is 35.2 degrees north. And because of the way the Earth rotates about its axis, pretty much anyone at the same latitude is going to share the same sky. And so cultural astronomy is a really neat opportunity to look at the variations in cultures as they're shown in the night sky. So when we look up at the night sky, all of those beautiful stars are points of light, and different people connect the dots in very different ways. So this is a scene of what you would see tonight, about 8 o'clock, an hour or so from now here in Arizona. You may be seeing this earlier or later, depending where you are right now. And so we have the Pleiades and Venus really close together. And we'll zoom in a little bit here. So we've got Venus passing right through the Pleiades star cluster. And this line here is the orbit of Venus projected into space from our perspective. And this here is a close-up view of the cluster. This is from Robert Neville, who worked here at Lowell Observatory in the late 50s. And so this is a nice image showing a lot of nebulosity and quite a number of stars. Now, if you have polluted city skies, you might have trouble finding the Pleiades, or maybe you're going to see just a small number, 4, 5, 6 of them. If you have incredibly dark desert skies, then you may see as many as 10 to 15 of the stars in this cluster. This here is the Nebra sky disk. It was found in Germany and dates back to the Bronze Age, probably to the neighborhood of 1600 BCE. And what's really interesting about the sky disk, this is most likely the world's earliest written record graphically of the Pleiades star cluster. So obviously, none of us were around 3,600 years ago, but the cluster of dots in the middle of this disk is most likely referring to the Pleiades. And so the Pleiades have been observed and recognized by cultures across millennia. When we look at Arabia, they had a very special relationship with the Pleiades. And we're going to see it was so special that this was the one thing in the night sky that didn't even need a proper name. It had one. This was called a Thuraya, which is difficult to translate, but it would roughly be something like the little abundant one in Arabic. And it may be that this refers to the dense concentration of stars that you can see in the star cluster, but it may also refer to the sense of abundance and plenty that comes when it sets before sunrise. It would have been about early November, perhaps late October, depending where in the Arabian Peninsula you were. And so, when the heavy rains come, when it sets, then you would have all of this abundance of plant life growing. And so that may also be part of the derivation here. Now, one of the earliest recorded quotations regarding the Pleiades, and again in Arabic it's Athuraya, goes back to Imru al-Qais. He was a desert poet before the days of Islam, died around 544 CE. And so he says, when a Thuraya inclined obliquely in the sky, like the variegated gems of a beaded sash, whose folds drape from shoulder to opposing waist. And essentially what he's doing here is he's visually describing the appearance of the Pleiades in the sky. You can see that in this orientation that I have the image presented here, then this would be the upper shoulder and the sash would go down like this where my cursor is. Well, this star cluster was so heavily celebrated in ancient Arabia that it was often referred to just simply as a nejm, which literally means the star or the asterism. So whenever you read old Arabic poetry, if it says the star and there's no name, we know that is referring to the Pleiades star cluster. So it was the star par excellence. And this is a really remarkable example of how the stars came to have shared cultural meaning. Because to be able to go outside, for example, in today's society and say, hey, the star, no one would know what you're talking about. But this particular star cluster was so celebrated that the star meant the Pleiades. So we can see this here in what's, I believe, the earliest example of the Pleiades in Arabic poetry. This is from Muhalhal, who died around 531 CE. And he says, as if the star, when it disappears just before dawn, were young camel calves roaming around on a rainy day. So he's comparing them to a bunch of young camels, young bright camels. Now, in both of these examples so far, we're looking at the setting of the Pleiades. And we see this as well in the Quran. So the surah of the star, which is Surat An-Najm, the same word referring to the Pleiades, the whole chapter there begins with, by the star when it goes down. So the pre-dawn setting of the Pleiades was really significant in Arabian culture. Now, over time, a Thuraya, or the star, came to become anthropomorphized. And so it developed arms and hands, and we'll see what that looks like in just a moment. But the star cluster itself, the Pleiades, or a Thuraya, would have been the head. And then there were two different arms stretching down to the western horizon. This asterism is best viewed as the Pleiades are close to setting, pretty much about now, as we see it in our night sky. A little bit after the development of Islam, we have another really famous desert poet, the Urumma, who used this phrase, the hands of the Pleiades. So he says, won't Mai come in the night to one amorously mystified by her mention, when the hands of a Thuraya reach for the western places of sunset? And so he's literally describing the picture in the night sky that we see right here. So we have the Pleiades, a Thuraya, right here in the middle of the red circle. And then we have two hands. Now this hand reaching in this direction is called the amputated hand, a kaf al-jazmat, because it's short and it doesn't have fingers like the other one does. The other hand was called the henna-dyed hand, and it goes all the way out here. And I'll tell you, if you're an avid sky watcher, when you connect the dots and go outside and look at this line of stars going all the way from the Pleiades to Greek Cassiopeia, you can't unsee that line. It's a clear line of stars, and this was the henna-dyed hand because one of these stars here is reddish in color. And so it reflected the orange color of henna once it's dried on someone's hands. In Arabic, this is called al-kaf al-khadib. And the last star in this hand here, today we still call kaf, reflecting that old Arabic name. Now this other circle is highlighting the famous double star cluster in Perseus, and that is visible with the naked eye. And in Arabia, that star cluster was seen to be the tattoo on the wrist of this henna-dyed hand. And then we have many stars going down the length of the hand that designate the forearm, the elbow, the pit of the elbow, the upper arm, the shoulder blade. It's really quite detailed. All right, so we also have a love triangle in the story of Thuraya. So you may have heard of a very bright red star called Aldebaran. In Arabic, we call this Aldebaran, and it literally means the follower. And the person that Aldebaran is following is a Thuraya. And so there's a love triangle in which we have Aldebaran following a Thuraya, and then another bright star called Al-Ayuk, which means the impeder or the preventer, who is preventing the two of them from getting together. And we can see this reflected here in the night sky. So once again, we have a Thuraya, and then this bright red star behind it is the follower, Aldebaran, and then above them is the impeder. And the story goes that Aldebaran was engaged to a Thuraya. A Thuraya is always seen as a female figure, and the impeder prevented them from getting together. And so forever, Aldebaran chases a Thuraya across the sky, but he never gets to her. Now, there's also a whole series of calendrical sayings that relate to the Pleiades. And some of these are in this format that use a structure called rhymed prose. Many think that it's a very early precursor to Arabian poetry. And I have on the left here the English translation, and on the right, the Arabic, so you can see how it sounds. So the translation says, when the star rises, the summer is vehement and the herbage is brittle. So of course, by the star, we mean the Pleiades. So we've already learned that when the Pleiades is setting, it's early November, and this is the time when the heavy rains are coming that mark the ground. But when the star is rising early in the morning, it's in the middle of the summer, and it's hot and it's dry. In Arabic, it sounds like this: إذا طلع النجم فالصيف في حدم والعشب في حتم. So you can hear that rhyme at the end of each phrase. Another example using Thuraya has each line of this rhymed prose talking about what happens when the Pleiades is at a different point in the sky. So we see it say, when a Thuraya is at the top of the head, then it is the night of a boy and an adze. When a Thuraya rises with the sunset, then it is the night of an offspring, and a camel. When a Thuraya sets with the sunset, then it is the night of wind and rain. So each of these different positions of a Thuraya is indicating a different kind of weather throughout the year. And so essentially it's an entire calendar just based on the position of a Thuraya. All right, so that's some examples going into Arabic lore and poetry about Thuraya, aka the Pleiades, in the night sky. And I'll just check here and see if there are any questions. Question, what star is the impeder? The impeder you would know today as Capella in the Greek constellation Auriga. All right. Looks like those are all the questions. And so I'll go ahead and stop sharing and turn it over to Jeff.
Okay, thanks, Danielle. That's a really interesting comment that, there can be things in the sky we've seen all our lives, but we've never really noticed them. But once we do, we can't unsee them. And maybe that's how we apprehend new things up there every night. So for our final segment tonight, we're going to switch a little bit and talk about the science of planets and planets around other stars. Now, earlier in the broadcast, you heard from Ariel that Venus is a very inhospitable place. The spacecraft that have landed on the surface of Venus have had about an hour or two to do everything they could do before they finally gave in to the horrific conditions on the surface. As technology has advanced, we are now beginning to discover just hordes of planets around other stars in the galaxy. Perhaps some of them like planets in our solar system, but many of them, particularly planets close to their host stars, that are wildly different from what we're seeing around Venus. And so for our final segment tonight, we have with us Dr. Joe Llama, who is one of the astronomers here at Lowell Observatory. He is an expert on exoplanets and the atmospheres of exoplanets and how they all work. So, Joe, if you could turn on your video. We're going to talk a little bit about the science of planets close to their stars and planets around other stars. So we'll let you take it away for a while, and then we'll come back for a final Q&A at the end.
All right. Thanks, Jeff. Good evening, everyone. So as Jeff says, I'm an exoplanet scientist here at Lowell, and my job is to try and find planets that are more probable for life, that are more suited to us, to life potentially forming. So why don't I get my presentation going here and we can have a look. So at the start, Nina talked a lot about how all the planets in the solar system are kind of in a plane. And she also talked about eclipses. And so this is an image from the 2017 eclipse that many of you, I'm sure, were lucky enough to view. So that's when the moon goes between our viewpoint here on the Earth and the sun. But what happens when a planet does that? Well, in our solar system, there are two planets that can do that, Mercury and Venus. And maybe many of you remember the 2012 transit of Venus. And so here I'm showing you a really cool animation. This is one of my favorite movies of all time in astronomy. This is the sun taken with NASA's Solar Dynamics Observatory. So that's a space-based telescope. And what you're seeing here is an extreme ultraviolet image or movie sequence of the sun during the 2012 transit of Venus. So you can see the planet there crossing across the disk of the sun. And so the obvious question is, do planets in other solar systems do the same thing? And could we see those from here on Earth? And so the original pioneer of my field, exoplanets, was actually Otto Struve in 1952, where he correctly says that one of the burning questions in astronomy is whether there are planets out there and how frequent they are. And this is back in the 1950s. And he even went on to show us some potential ways of how they could be detected. And one of those ways is through eclipses, or as we call them, transits. So he even goes on to estimate that should a planet the size of Jupiter go in front of its star, it should be ascertainable by modern photoelectric methods. Now, he wasn't quite right about the modern photoelectric methods. This was back in 1952. He was quite the pioneer because the first exoplanet wasn't actually discovered until the late 80s, early 90s. And so, but one thing we do as astronomers is we look for this exact
Hi,
signature.
Joe. Joe, this is Jeff. I'm not seeing your images. You might need to share your screen.
Oh my goodness. Okay. There we go.
There we go.
Okay, well, I'm going to go back and play the movie again because the movie is very cool. So this is an eclipse of the sun. Can everyone now see it? Just say in the comments if you can see it.
Yep, got it.
Okay, good. Sorry about that. Okay, so this is an eclipse when the moon goes in front of the sun. But when a planet goes in front of the sun, it looks much more like this. So you still see the actual disk of the sun. So this is an image from SDO, NASA's Solar Dynamics Observatory. And what you see here is the transit of this back in 2012 across the disk of the sun. And so, as I said, one of the pioneers of this exoplanet field was actually a man called Otto Struve back in 1952, where he correctly said that should a planet around another star do the same thing from our vantage point here on Earth, we should be able to detect that. And so this animation here shows one of the ways that we actually search for exoplanets. So as the planet moves in front of its star, it blocks a fraction of the star's light. And so by using very precise measurements, by taking very precise measurements of stars, we can actually measure the light as a function of time, looking for these dips in light. And this is a really powerful because it allows us to learn a lot about an exoplanet. And so on the left here, I'm showing you what happens when a planet the size of Jupiter orbits in front of its a star like our sun, and you get about a 1% dip in light. Earth, or Venus, is much smaller than Jupiter, and so it blocks less of its star's light, and so it produces about a 0.01% dip in light. And so by measuring the amount of light blocked during a transit, you can estimate the size of the planet. And so this was really pioneered in the early 2000s by ground-based surveys and then eventually by space-based telescopes. The ground-based surveys were able to find many, many planets the size of Jupiter, but orbiting much closer to their star. And then in the 2009, NASA launched the Kepler spacecraft, whose goal was to find a planet similar to the Earth around a star like our sun. And it didn't quite achieve that, but what Kepler did was it stared at 150,000 stars and took incredibly precise measurements of the stellar brightness as a function of time, searching for these periodic dips in light. And Kepler was incredibly successful, but unfortunately didn't last its mission duration. It didn't last long enough to actually find an Earth around the sun, a star like our sun, but it did find thousands of other exoplanets. And so the successor to the Kepler mission was actually the Transiting Exoplanet Survey Satellite, that's TESS, as you can see here. And TESS launched back in 2018, and its goal is to search for planets, again, like our Earth, but this time much closer to their star. So TESS is really looking for planets at similar orbital distances to Venus, but around stars much smaller than the sun. And so because the star is smaller, the temperature of the planet will be much lower because the star is giving out less flux, less heat. And so it's thought that planets could exist in the habitable zone at similar orbital separations to Venus around the sun. And so this is just a really cool schematic of how TESS observes the sky. And so it observes in these 27-day blocks, and it sort of scans across the sky. Then after a year, it flips over. It's just done this, and now it is observing the northern part of the sky. And so it maps the whole sky, searching for these planets, these short period planets around probably smaller stars, trying to find potentially habitable worlds. And so to give you an idea of how many exoplanets we found, this is a very cool animation by a then graduate student up in Seattle. And it shows you in the center, the dashed lines here are the solar system planets. And then to scale is every exoplanet that we found. And so what you see is we see this amazing plethora of planets. We see planets orbiting really close to their host star, like this system here, and then we see some more further out systems here. But most of these planets that we found have orbits much closer into their star than, say, Jupiter does in our solar system. But the planets themselves are similar, can be similar in size to Jupiter. And so one thing we've really learned as exoplanet scientists is that basically any configuration of planet is possible. And so I think that's a really cool result. And one of the other things we've learned that I think is one of the most powerful results is that statistically speaking, every star you see in the night sky has at least one planet orbiting it. And so planets are everywhere is kind of the bottom line. And so this plot shows you the current state of affairs. So along the horizontal axis here is the separation of the planet in terms of astronomical units, where 1 astronomical unit is the distance from the Earth to the sun. And then mass in terms of Earth masses on the vertical axis. And then I've also included the planets, Jupiter at the top there, then Earth at 1,1, and then Venus down just below the Earth there. And what you can see is we haven't found any planets similar in size and orbital separation to the Earth and to Venus. And that's kind of the next goal. It's a really hard measurement to make. And so that's something we're all working towards, especially here at Lowell. I get to tell you now about some of the prospects for finding these planets, and how Lowell is playing a critical role in doing that. And so here at Lowell, the method we're using to find planets is not actually the transit method, but the radial velocity method. And so as a planet orbits around its star, it actually exerts a gravitational tug on the star. And so the planet orbits the star, but the star also slightly wobbles because of the presence of the planet. And you can see here in this animation, as the star moves towards us, the light from the star gets blue shifted away, and then as the star moves away from us, the light gets red shifted. And what we can do is measure the amplitude of that shift using incredibly precise instrumentation that we have on our telescope to try and search for planets. And so that's where the Lowell Discovery Telescope comes in. We recently partnered with Yale University to build the Extreme Precision Spectrometer. It is now mounted on the Lowell Discovery Telescope. So our 4.3 meter telescope just outside Happy Jack, Arizona, is now home to one of the world's best spectrographs. And so this is just an image of the spectrograph itself. It was built by Yale University, and it is capable of measuring the wobble, the amplitude of that shift in stellar light down to an amplitude of about 20 centimeters per second, which is just incredible precision, which is enough to almost get us to find an Earth. And so by night, we use it on the Lowell Discovery Telescope to try and search for true Earth analogs. So planets same size as the Earth, around stars like the Sun, but at 1 AU, so at the same distance as the Sun is, as we are from the Sun, to try and really find a habitable planet. And so this is just an image of what the data that comes out of Express looks like. It's this beautiful spectrum. You can see the red light at the top there going down to the blue light at the bottom. And you can see every dark strip there is a stellar feature that we use to measure how this wobble in light, how large this wobble in light actually is. But that's what Express is doing by night. But during the day, the Lowell Discovery Telescope and Express are just sat there. And so one thing I've been working on very recently is commissioning Lowell's newest telescope. It is the Lowell Observatory Solar Telescope. The Lowell Discovery Telescope is a 4.3 meter. The solar telescope is 0.07 meters. So it's a 70 millimeter diameter optic. It's very small. You can see it here next to the LDT. And with it, we will observe the sun every clear day to try and inform our observations of stars at night. And our goal with this telescope is to better understand the impact of things like star spots, faculae and plage, coronal mass ejections, all these things, activity features you see on the sun in this data we're getting at night to try and discover and recover a true Earth analog. And just to link it back to Venus as a bonus, because we're observing the sun, we will also be observing the radial velocity pull of Venus. And so our hope is that we can actually pull Venus out of our data and try and discover it, just like we would discover an exoplanet. And so with that, I'll stop there.
Okay, thanks, Joe. So yeah, this is a really interesting new era in stellar activity and exoplanets at Lowell Observatory. I've been studying basically all of the things that give Joe a huge headache are my bread and butter, because I'm interested in studying the stellar activity and the variations of the stars. And the real beauty of the solar telescope that Joe just described is, you remember back to your first year in college when you had a textbook and you had a really tough problem to solve, but all the answers to the odd number problems are in the back of the book. And the thing about looking for Venus is we've got the answer in the back of the book. And so if we can pull Venus out of the data, right, Joe, it gives us a lot of confidence in our ability to pull those tiny little signals out of the planets around other stars.
That's right. So the signal, Jeff's signal is kind of my noise. So Jeff is really interested in what the stars are doing. I want to try and find the planets. And so, yeah, that's absolutely right. And so because we know the answer for Venus, we know its mass, we know its orbital distance from the sun, we can exactly search for it in a blind way, just like we would for planets at night, and see if we get the right answer.
Right. Now we do have a few questions coming in on the feed. Jim Davies, hi Jim, thanks for tuning in again. Jim wants to know how many planets are rocky. Joe, your point, if there's planets around most stars in the galaxy, there's 1 trillion planets out there. And one thing we know is there's lots of different architectures.
That's right. And so basically, if you can imagine it, it pretty much exists. And so the actual number of rocky planets is sort of up for debate. It's very hard to measure the actual composition of an exoplanet, but we know of certainly many, many planets. So in total, we found of order 4,000 exoplanets, and a good number of those we believe are rocky. And so Jim also asks, the solar telescope is an object used with the same base of the Discovery telescope. So that's right. So the solar telescope will live out by the LDT, but it will have then a fiber that feeds into the spectrograph itself. And so during the day, we can flip and use the solar telescope. We can allow light from that into Express. And at night, we can turn that off and use the light coming from the telescope itself.
Right. That's the neat thing about these fiber-fed spectrographs, which we've been using here at Lowell for 25 years, albeit a much older and less precise one than we're using at the Lowell Discovery Telescope now. You saw Joe's picture of it. It's 2 stories below the telescope floor, and it's enormous. So you would not want to hang something like that off the back of the telescope. You can use these cool little fiber optics to pipe the starlight down into this incredibly stable and precise system and do these measurements that basically it's the most powerful telescope spectrograph combination really in the world to do this kind of work.
Yep, absolutely. We're really fortunate to have it at Lowell, and we're going to get some great results.
Okay, thanks, Joe. So now it is exactly 7:30 here in Flagstaff, Arizona. Despite the technical glitches at the start, we're right at the point where we intended to end the broadcast. Fully dark here. Certainly it is across the rest of the United States. So take a look outside at the site that Nina and Ariel and Kevin and Victoria and Danielle and Joe have been telling you about. The sky is a source of storytelling and solace, and particularly in uncertain times, it's a little bit cathartic to go out and just look at the stars wheeling by overhead, and maybe gives us a little bit of a steady compass when things are changing so rapidly around us. We're going to be coming back to you next week with a couple of more events to talk about next week's full moon, Lowell and Flagstaff's role in exploring the moon. Kevin Schindler, who talked to you tonight, will be online for a lot of inside information about the history, all of that. In the meantime, we sincerely hope all of you have peace and good health and safety during these times. We'll continue to try to bring you some neat content from here in Flagstaff. Good night and have a great weekend. We'll see you next week.